I want to talk to you about design convergence. I'm sure most of you, not all of you, are familiar with the Bio-Convergence concept. So Bio-Convergence is kind of a very trendy, if you will, and evolving concept, especially within the life sciences and technology sectors. And basically what it means is that we're in an era, that's a theorem or a conception that I truly subscribe to, where probably, I guess in any generation, people say for the first time in history, ... But truly for the first time in history, in the past, I guess, 10, 15 years, we've been able to integrate practically, physically, the three kind of major components of the universe, at least as we know it, which would be the physical matter, atoms, right? The digital matter, bits and bytes, and the biological matter, be it proteins, etc. So the basic component of our universe, at least, the measurable components, the things that we can actually measure and use, can now be integrated. And that is an absolutely new thing. That was not possible 20, 25, 30 years ago. I guess 50, 60, 70 years ago, we could already, depends on who you ask and where, you could argue that you could implement two of them, right? The digital matter and the physical matter, and probably the biological matter and the physical matter, the atoms and the proteins in a way. But for the first time in history, in the past few years, we're able to combine all three. And that is a true and absolute revolution. And I'm sure, unfortunately, I couldn't join the entirety of Rory's talk, but I've heard him before and I read his writings. And I'm sure he mentioned, maybe not in these particular words, in these particular terms, but I'm sure he mentioned some of the visions and actual things and innovations that are happening, it could happen and will happen due to this truly amazing and incredible ability, supported or facilitated by us as a human species, but with an absolute integration and participant of nature. Which, by the way, I'm not going to discuss this, but for me, that's one of the fascinating questions in front of us right now, us versus nature. Or us with nature, or us being part of nature, et cetera, et cetera, et cetera. But that's for maybe for another day. And so what that allowed us to do is to create new things, new machines, new systems, new conceptions, new creatures to reach new places. And what I've been working on and with in the last few years, so I'm sorry, I apologize. So that would be kind of the concept of bioconvergence. And within that realm, there's a lot of activity these days. Within the industry, the academia, research, the government sector, the social sector, and so on and so forth. Here's the thing. The scientists and engineers, and I realize that I'm being extremely stereotypical by saying that, and I'm just saying that for the sake of discussion, that they tend to neglect one thing, and that one thing is us. So they tend to neglect our needs, our desires, our preferences, our behaviors. They do see us as subjects or objects for experimentation, as clients, as customers, as kind of the end users for new drugs, for new cars, for new microclimates, for new phones, et cetera, et cetera, et cetera. That would be true. But we're not part of the equation. And by design convergence, I try to implement, or we rather try to implement the design as kind of the ambassadorship, if you will, of the agency of us as humans and of all living creatures into this equation. So that could, in very, very general terms, that would be the idea of design convergence. So within that realm of these new materials and these new abilities to use technologies, science, biological sciences, biological materials, digital materials, etc., in new ways, it's on us as designers, as at least we see it, to embed or implement the human need, the human values, universal global values, and also the needs and preferences and desires of other creatures as well. Kind of non-human living things, if you will. in comes the DesignTist. So the DesignTist concept is, again, is a methodology that I've been developing in the past, I guess, 6 or 7 years. As you can imagine, it's kind of a fusion and integration of two words, the designer and the scientist. But aside from the actual linguistic pun, it is also a doctrine, a methodology, and a practical one that we operate with, and try to create things that, at least in our view, in our vision, could be meaningful and valuable. And I'll try to give you a couple of examples. Nika, I'm assuming I can share my screen, right? Cool, thank you. I appreciate your patience. And I'm not gonna apologize for my, for the mess on my desktop. Actually, it's not that bad. So, okay, so you're getting, Nikki, you're getting a free, a free promo of 50 seconds. So again, my apologies, this is not a dedicated presentation. So I'm gonna switch between a couple of things. Actually, I'm gonna start with this, maybe. Yeah, all right. So, so may I introduce to you Eclair? Eclair is, it's a project, kind of an ongoing project. I started along with my project partner, co-founder, if you will, Luther T., who is an American programmer and designer. It started basically as a thesis project or master's dissertation, if you will, as part of our master's degree in Italy. And I'm beginning with this particular image because it kind of encapsulates the entire idea. So as a couple of designers and researchers, we've been playing with what now is called BCI, is brain-computer interfaces, for a while. I'm talking back in 03, 04. So wow, that's 15, 16, 17 years ago already. And we tried to find, it was a new field then. What you're seeing in this particular image, particular photo, is basically the first, it's not the first version, but it's the first BCI or consumer BCI product manufactured and distributed by a company called NeuroSky. Now there are probably 2,000 or maybe 3,000 different companies manufacturing these things for different purposes, but they were the first. An American company based in, surprise, surprise, Silicon Valley. Actually San Francisco rather. And basically their target audience was gamers. So they developed this particular device, this particular system for gaming. What was unique about this system, again, now it's less so, but back then it was pretty unique, is that it's quite, as far as consumer devices and as far as something you put on your head, which is always, from a design perspective and a human experience perspective, extremely complicated. Putting something on your body is really hard to design. Putting something on your head is tenfold, even more complicated. People hate putting things on their head. As you know, I mean, even putting glasses on your eyes, I just took off my glasses because after 20 or 30 minutes, it becomes a little bit cumbersome. It's something that is not easy, it's not natural for us. So they've been able to do that at least somewhat. And just quick word, what basically this particular device and nowadays others do is they measure in a quite rough way. So the resolution is not very high. Resolution as far as the signal is concerned. Basically, they measure the EEG. So you can see that the spot here, basically in the middle of your forehead, what is called the prefrontal cortex. So there's an electrical currency being transferred here that is analyzed by the algorithm as an EEG signal. And another signal that they analyze is called the EMG, the myogram. So to an extent, this device can measure the movement or the delta in the movement of different muscles in your head, basically on your face. So there are about 440 different muscles in your head. So they're pretty sensitive. So basically the idea was that combining these two signals, now there are more, but back then would give you a rough idea about the relationship between your physical movement, in this case, the head and the face, the brain, and then the connection could arguably be made to your cognitive state and also to your emotional state. So that would be an extremely rough explanation what this device, this system can do. Again, back then, now the case is different. Back then, it was not up to the scientific standard, but it wasn't that bad, as a matter of fact. So for our purposes, it was good enough. So basically what we did was we tried to use this machine, this device, very simple device, basically a wearable computing device for different purposes. So we used it in airports, we used it in kiosks and supermarkets. And in this particular project, we used it in museum. And I'm bringing this particular project, this particular example, because it was, again, back then it was quite provocative in its approach. So what we did was basically created a kind of, we created an algorithm that functioned as what we call the curiosity algorithm. What we did was we let people travel and go through and walk through different, I'm just going randomly through different images, different galleries, different experiences, different exhibitions. Let me try to, yeah. That actually took place, Johan, in Eindhoven. So our first implementation of the project was in Eindhoven. There were a few of those in the Netherlands. We did in Copenhagen, in London as well, and in the US. And so the idea was this. You would get this device, carry it on your body with an app that we developed. You would do your walkthrough. So you walk through the exhibition. In this particular case, yeah, that was in Eindhoven as well. So in this particular case, just as a kind of a part of the exhibition, a part of a spectacle, we projected the actual brainwaves in real time on the wall. That's me explaining a visitor what's going on there. But that wasn't kind of the gist of it. The gist of it was that, and let me get to maybe, yeah, so again, just to kind of to show you. So this is kind of a 3x4 screen. You can see here 10, you can, the photo is not that great. You can see all of them, but there are 10 different brains really here. So basically there are 10 different people walking around with their brains and brain reaction projected on the huge wall. So yeah, so okay, I was trying to get to that. So the idea was that you would walk through, experience the artwork. We would analyze your brain reaction, brain responses, and give you a score. We can talk about later about how we actually calculate the score, what it means, but the idea was that we basically gave you a score for quote unquote curiosity. So basically that meant how engaged were you, how concentrated were you excited or not? So as you can imagine, the more engaged you were, the more concentrated, the more focused, the more excited, the higher the score was. And basically, if you got, I think 75 and above, or 80 and above, something like that, that was totally random, of course. You would get you get something in return. You would get a present or a free gift card, or I don't know, a free cup of coffee at the museum's shop or cafeteria or something like that. The gimmicky part is clear, but the idea was that basically you got something tangible for your bio data. So you would give us, quote unquote, give us, everything was, of course, was done consensually and with explicit consent. But the idea was that you actually could get something for your data. And that something could be a cup of coffee, but that something could also, and this is something we implemented with a couple of airlines, could get an upgrade for first class or a cheaper ticket or whatever the case may be. The idea being that the same test, basically the same test, only for different purpose, would take place in the airport as part of the security process. So you basically voluntarily give us your most private kind of possession, which is your biodata. We would use it for our purposes, in this case, the security purposes. And in return, you get some kind of a gift, something that is could potentially be meaningful to you. So as you can probably figure out, the idea in itself, in its foundation, was pretty provocative. There are security issues here. There are privacy issues here. There are different ideological stances and positions here. Obviously, that was part of our intention here. So basically, it was kind of technology meets science, meets the human condition, meets politics, et cetera, et cetera. It started out as a school project. It still takes place in several locations. Although we're not, Luther and I are not particularly involved as we were a decade ago, but it kind of emerged into a monster, if you will. One last comment about this particular project. At a particular point, I think it was 2007, we presented a version of this in an exhibition in San Jose, California. And I was explaining, so we basically we tricked people into believing it's a real company. So obviously for ethical reasons, everybody were debriefed afterwards. So nobody left the building thinking we're still a real company. But for the sake of the experience, we present ourselves, you know, I was all shaved and wearing a suit and tie, et cetera, all corporate America style. But we present ourselves as a real service, as a real product. And we had people signed up for the procedure, basically agreeing to freely donate and volunteer their data in return for some kind of a financial or otherwise tangible benefit. We assumed that most people would not do that, would disagree. Also, given the fact that we were in Northern California, which, as we all know, is quite a liberal area. And we were shocked to find out that 95, 97% of the people actually agreed to sign up, other than one person who actually beat me up physically. He attacked me physically. He was outraged by the idea of us kind of enticing people to forsake their privacy and kind of their most private possessions in return for basically for money or the equivalent of. And he got so enraged that he tried to attack me physically. It wasn't very strong, but it wasn't very powerful, but it was really angry. So that was an interesting experience and very educational for me. I'll move on very quickly. I want to show you a couple of more examples. Again, if you have any questions or comments, or please feel free, by all means. Let me move on to this. I'll just show a couple more projects. The idea being that, and I'm actually focusing on the more kind of edgy projects as opposed to startups or companies that I started, which obviously are a little bit more contained in terms of their, how far you can go, how provocative you can be, and kind of the science fiction meets what we call social fiction, is limited because we had to actually produce a product and approach a market. But that said, there are a couple of projects that the practical approach is actually quite dominant there, although they haven't been realized yet. So this is a project started by a student of mine. We did it together afterwards. And again, I'll just describe it very, very briefly. So the context is we've been collaborating with Microsoft. So Microsoft R&D center here in Israel, in Herzliya, not far from Tel Aviv. And they approach us dealing with the kind of the global issue of emergencies. So they wanted to find a way to effectively use their own technologies, including their service, data, cameras, everything that is physical, digital that they have in their disposal to try to either prevent or predict emergencies. There was one traumatic event in their history that kind of gave rise to the idea, and that is that an ex-Microsoft employee who came back, who was fired. His ex-wife was also a Microsoft employee, and now back then he's train driver already. Basically, he left the building, physically left the building after having a kind of a divorcee's fight with her. Came back, called her up, asked her to meet him in Microsoft in the campus parking lot, and murdered her. And so the idea was, obviously there was extremely traumatic event in the kind of basically the history of the company, and what they tried to do was find a way to use technology to try to either predict or prevent these type of cases. So that's kind of the overall or the overarching idea or concept. And what this particular project was about strokes, and I'll explain. I'm sure you're all familiar with the bystander effect. So just kind of in one sense, basically it's a psychological phenomena identified in, I think, 1968, based on another trauma that took place, a murder that took place in New York in 1964, where, as you can clearly see from the headline, Kathy Jane Vesey, a young woman, was brutally murdered in the streets of New York. In Manhattan, I forget the exact address right now. And from the police investigation, it turns out that 37 people either heard her scream or actually saw the actual event, actually murdered, and 0 of them, nobody called the police. So the question was why? And what came up with this ongoing kind of research, and of course they investigated and explored other cases as well, is the effect now called the bystander effect, which basically translates to distributed responsibility. So basically, if you stand by yourself and watch some kind of a crime taking place, the probability that you will do something, any kind of action, call the police, intervene, call for help, maybe even go home and then call the police, something is extensively higher than the situation where there are 10 of you standing on the street, either seeing each other or not, and then the chances are nobody will do anything, because the idea being that why should I intervene? Why should I do something? There's clearly somebody else out there, so somebody else should do that. So that would be the bystander effect, which of course could lead to lethal cases like this one. By the way, one kind of a practical recommendation, all of us here are men, which is an interesting observation in and of itself, come to think of it. But there's a clear recommendation to women who are being raped to shout or scream fire. And I'm curious to ask you, I would ask you why do you think that is? But for the sake of time, I'll just say that the reason is, again, probably this, some of you know already, the reason is that if I'm a woman being raped and I'm asking rape, and I as a man or as a bystander can hear you, it doesn't affect me. I mean, it does affect me as a human being, but there's 0 chance that I'll be raped at this particular point. So the chances are that I will not intervene, as the research shows. But if a woman shouts fire, screams fire, if there's really, if I think there's an actual fire, it might affect me as well, right? So the chances of me doing something, calling in for the fire department, the police, are much higher. So if you're a woman being raped, paradoxically, the chances of for help are extremely higher if you're shouting fire and not rape. Anyway, so using this principle, I'm just skipping through the slides. What Yaniv, my student, and I did was taking a look at the situation of a stroke. So Yaniv's father, I'm just looking for the actual photo. So Yaniv's father died of stroke, of brain stroke. I myself I didn't have a stroke, I had a heart attack 5 years ago, regardless in a public scenario, in a public place. And the kind of the problem, the challenge we dealt with was what happens if a Microsoft employee, again, to remind ourselves, we're talking about an emergency situation in a Microsoft environment, gets a stroke or having some kind of a medical issue. And the idea here was, so the idea for Microsoft was, let's use our AI capabilities, all the data that we have, to try to predict who might get a stroke, who of our employees might get a stroke or heart attack or any kind of a crucial medical situation. What we did was basically adding the AI data or AI platform and adding to that the human factor. So again, I apologize because I didn't prepare. I can't find the actual image of the cafeteria. So imagine a cafeteria space. Okay, so let's assume this cafeteria is a Microsoft cafeteria. There are different people eating there, and there's a person showing signs of stroke. That could be sweating profusely, twitches in the faces, a partial paralysis, so maybe saliva coming out of the mouth, something that would look to the people around them would look strange. But even if something does look strange, it doesn't mean that I'll start shouting strokes, right? Or I'll start approaching them, because I might be wrong, and that might be an embarrassing situation for me. So the idea was that at this particular point, the automatic system, the technological system, let's say a camera in the cafeteria would recognize in some kind of a facial recognition technology, which again, everything is already implemented. There's nothing new about that. Would recognize so that Eyal's face are acting strange, basically. There's something different from the usual behavior, either bodily behavior or facial behavior. So that would be phase number one. Phase number two would be, okay, so what do we do about that? What's the decision-making process here? Again, without trying to embarrass anyone, either myself as the one having the stroke or the people around myself, and without trying to make any kind of a false positive mistake. So the phase two, and this is where our project took place, would be to find the right person in the neighboring environment, so people around them, to find the right person around, let's say me in this case, to approach me with the right message. So there's a decision to create some kind of an operation to act. There's a decision to identify the right person, and there's the decision what to do. What this person do? And the idea was, and this is the application we developed, that let's say I don't know, Moses, my friend, who sits by my table, would get a message on his phone that would say, "Look at Eyal, there's something wrong." Okay, and gently asking if everything is all right. So that, for example, that would be kind of a logical, reasonable approach. So that would be kind of a fusion and integration of the AI or the data-driven system and the human kind of empathy, if you will. A different situation would be, let's say, if the identification or the decision would be that I'm in a grave state, so there's immediate tech action that should be taken. So the system could actually find out who has the best, let's say, medical training within the facility or the vicinity of the person in distress, and then have them act, et cetera, et cetera, et cetera. So, so again, in this case, our intervention, or our value was, and this is kind of the quote unquote DesignTist value, was the integration of the AI system and the human factor, or the human empathy. I wanted to conclude. I'll just give you one more, quite a poetic example, a project which I love, I personally love. It's not my project. I supervised it, but it wasn't mine. And I adore this project. So we had this collaboration with the Brain and Vision Lab at the Weizmann Institute. The Weizmann Institute, I'm sure most of you, again, if not all of you have heard of it, is a prominent research scientific institute here in Israel. We work with, as part of the Brain and Neurology department, we worked with the Vision Lab. So let me see if there's, yeah. Okay. So they had this research. Let me maybe try to go to presentation mode, maybe. And again, I promise I'll be very brief. So their research was revolved around the idea that for people who are blind or have a very extremely limited sense of vision, can actually sense objects or quote unquote see objects through a sensation in the finger. So it turns out that especially in the fingertips, which are extremely sensitive, or sensitized rather, and the V1 area, which is the primary vision area of the brain located in the back of your head, are connected. And so they, for 6 or 7 years, by that time, tried to create a device, a system that would enable the blind to basically actually see, so have their brain see objects or see the world through their fingers. By the way, again, back then it was there were 6 or 7 years into the research, raised an astonished sum of $50 to $60 million in grant money and research grant, and they haven't spoken to or haven't met one blind person. It was all done in the lab, and they didn't even bother, it's not that they didn't bother, they didn't think it was important or meaningful enough to actually summon people who actually suffer from the problem they're trying to solve and have them take part. So obviously the first thing we did was go out and talk to people who are blind. And obviously it was extremely educational and fascinating. So what you see here is Dana, one of the researchers who was involved in the project, she has her eyes closed, and she's trying to quote unquote see the apple through this extremely, cumbersome, robotic-looking design or device, and basically sensing the apple through her apple. So, quite the reverse of it. Set the apple through her fingers, through her hand. Obviously, it's not something you can do with the first attempt. It's something that is learned. The body has to adjust and change. But the actual experience is extremely interesting. So we were helping them with developing an actual device. In this case, it was a glove that you put in your hand, and you basically play your fingers like playing a device, playing an instrument, playing the piano in the air, kind of an air piano, air guitar, as the game goes, in the air, and basically sensing your environment. So that was the goal. But here comes Joe Bang. Joe Bang was a Korean student of ours, a brilliant, this was one of the researchers, a brilliant designer. And he asked a different question. And I'm trying to get to, these are all part of his experiments. Pardon me. I'll try to speed it up. Okay. So he asked a different question. He said, okay, so I understand that conceivably with this device, with this system, you can move your fingers, move your hand, and see, as at least from the neurological point of view, you can see or experience seeing an object. Let's say a chair. J-Bong was a furniture designer. So he saw the world in a way through furniture. So I can understand how if I was blind or if I had my eyes, it was blindfolded, I could see the chair through my fingers. But then again, what about the beauty of the chair? So can I tell if the chair is beautiful in my view or not? And this is an incredibly important and meaningful question, because this is a question that most, if not all, scientists would never ask and would never think of asking. But then again, it's extremely and absolutely fundamental to the experience of seeing, because when we see things, part of the experience of seeing is not just diametrically or mathematically and identifying whether it's a chair or a lamp or a wall or a person. It's about the experience of what we're seeing and how it affects us. So the actual quote unquote beauty of an object, in this case a chair or an apple, is essential to the experience of seeing. So obviously the scientists were flabbergasted, as by the way we were, because it's an extremely important and obvious question, but nobody asked. And he was experimenting with trying to identify and explore whether or not people can actually see, or blind people rather, can see beauty. I'm just going to run through. So experiment, he had different kind of what we call 2D and 3D experiments. So that would be a 2D experiment. So something that is graphically on a page or in a paper. He would show it to people who are blind and ask them to experiment with the technological device and then draw something and figure out whether it's beautiful or not in their, obviously in their subjective eyes. And then he would 3D print, in this case, this is an iconic IKEA chair. So that's real size. So he 3D printed a tiny IKEA chair and had people try to identify it and try to see if they can actually identify that it's an iconic chair and whether the experience is beautiful or not. I'm going to stop here with J-Bone's chair and stop drilling. And again, just leave you with this. So this kind of DesignTist concept or design convergence idea of integrating or employing the human condition, the human experience into the science and technology at its highest level, and try to implement this into real world project and solution is the thing that we're striving for. So thank you so much for your patience, and obviously I'm open to questions.